Here we go with the third part of section 7.3. Now we are looking at the quotient rule. So you saw in the last video we were dealing with the product rule. So that was anytime you are multiplying terms together and you're trying to find a derivative. Quotient rule is anytime you are dividing terms and trying to find a derivative. So in this case, again, we're going to look at what you could do with the older approach, and then we're going to look at the new approach with the quotient rule as well. So the older approach would say, let's just take this x and divide it into each term individually, which is going to give you this look right here, and then use the power rule on each term separately. And so you would say, okay, well, now that I've separated out all the terms with pluses and minuses, I can now apply the power rule. So this would just give me 2x to the 0, which is 2. My constant would go away. I would do negative 1 x to the negative second, and you could get this look here. And that's one approach, and yes, it does work for some cases like this. This would work for this case, but there's just plenty of cases where you really can't take that approach, and so you got to be familiar with the quotient rule. But here's what it looks like. If you consider this look here, so keep this in mind, whatever is on top is the u term, and whatever is in the denominator is the v term. And so if you stick that in here, you're looking at the bottom term, times the derivative of the top, minus the top term times the derivative of the bottom over the bottom squared. And so the way I've always heard this was low d high minus high d low over low squared. And so that's essentially what we're doing with the formula. But keep in mind, you don't have to memorize these. That is also in your formula packet. So you got the quotient rule right here. And so they're pointing out that the top term is u and the bottom term is v, and so if you just kind of put it in here where the formula tells you to place them, you should be okay. I do have students mix the order of this up, and that causes a problem. You guys know that subtraction order matters, so it's really important that you start with the bottom term right here and then work your way forward. So keep that in mind, but you have that formula available to you. So where are we at? So going back to the lesson here, so let's look at the same problem that we did up top with the new method here of using that quotient rule. So if I did the bottom term, so here's the bottom term, times the derivative of the top. So again, I'm just using that power rule to get the derivative of the top. So you would do the 2 times 2 and then subtract 1 from your exponent. So you got the bottom times the derivative of the top minus the top term times the derivative of the bottom, but the derivative of x is 1. So you could write that or not write that. It really doesn't matter. It's not going to change anything. And then on bottom, you have the bottom squared. And so that's always the setup for using the quotient rule. Yes, you do need to simplify, so please don't leave it like this. We would need to, in this case, distribute the x. That's going to put you all the way to here. And then if you combine like terms, you get it to this stage. So there's always some debate as to how you're supposed to leave your answer for this. This is one way. You could leave it like this. You could divide each term by x squared and get this look. Arguably, neither one is really simpler than the other. So if it just says simplify your answer, you could do it either this way or this way. Again, just check the directions and see if it asks you. But you do need to simplify within reason. So, obviously if I can combine like terms and do those things, you should do that. But I would say either this is a reasonable answer as well as this. This is just another form of the rule, though I don't really want you to get familiar with this because this is the one that's in your formula packet. So I'd rather you get comfortable with the first one that you see up here. So just a few examples, and again, at some point you should pause the video and give 1 or 2 of these a try on your own. But you can see that obviously we're dividing, so we're going to apply this quotient rule. So again, anytime you're trying to find a derivative and you have a fraction, so you got division going on, and you got a variable on top and a variable on bottom, automatically we would go to the quotient rule. So we have our bottom term times the derivative of the top, minus the top term times the derivative of the bottom over the bottom squared. And so that's always the setup for the quotient rule. And again, you should simplify as much as you can. So notice on this one, you could simplify the top all the way to 3. And this would be a great way to leave your answer. You could expand this and you could do the, you could rewrite that as x squared plus 6x plus 9. But again, you couldn't really say that that is simpler than this. It's just a different form. So, you could expand it, but you don't need to. That would be a good way to leave it right here. Again, right here, just another example. You got your bottom term times the derivative of the top. So again, always for doing these derivatives, you're just applying the power rule. So again, you multiply the 3 to the front, subtract 1 from your exponent, you got your 3x squared. Minus the top term times the derivative of the bottom over the bottom squared. And again, as you go through, simplify as much as you can within reason. So if I distribute this and then combine like terms, I can take it all the way to this stage here, and I would argue that this is an okay way to leave your answer. Or you could factor out the 2x squared and leave it in factored form like this. But I would say that either this or this would be an acceptable, reasonable, simplified as much as possible kind of a form. So again, one more here. You got your bottom term times the derivative of the top. So remember, the derivative of a natural log of x is just 1 over x times 3. Sometimes, once we introduce the product rule, students start trying to apply it to cases like this. They look at this and they say, oh, well, this is 3 times the natural log of x, so I should apply the product rules for that. Well, you only need the product rule if both terms contain x's. If it's just a constant like this, you don't got to do a product rule for that. So the natural log of the derivative of this is just 1 over x times 3 is going to give you 3 over x right here. And so that's all you have to do. You don't have to apply the product rule unless both terms contain x's. And then right here you got the top term times the derivative of the bottom over the bottom squared. And so if you clean all that up, you're going to come away with this look here. And again, you could factor out the x squared. This would be a case where I would argue that you should factor out the x squared, because if you do, you can see that these can reduce. And this would be what I would suggest a simpler look to your answer. So it's always worth checking to see if you were to factor something out, can it simplify with what's on bottom? Because if it can, yeah, that is a simpler look. And so this would be the most appropriate answer right here. This is just kind of some more of the same. So I'm not going to walk through this last example, but it would be a good one for you to try on your own if you want to give one a shot here. So going down to part B, this is the end of the line here for these notes. Again, you're now looking for the equation of a line. So two things about this. One is, you're automatically thinking point slope. And then this word right here has to stand out to you. So if you see the word normal on a test, highlight that thing or underline it or circle it. So this is the word that tells you perpendicular. So remember, the word tangent does not mean perpendicular. I have students make that mistake all the time on tests, simply because it traces all the way back to geometry. Anytime you have a line that's tangent to a circle, it is perpendicular to the radius, and so that seems to be where students trace that back to. So remember, tangent does not mean perpendicular. Normal means perpendicular. So for this one, remember, I need a point and a slope. The only thing I'm given to start with is an x coordinate. So I'm going to get my y coordinate by subbing this guy back into the original function for x. That's going to give me the y coordinate. And that's what you're seeing right here. So here's the y coordinate of 2. So the only thing left to do is find my slope. And I'll always get that by the use of the derivative. So obviously this is set up for using the quotient rule. So for this one, if we do our bottom term times the derivative of the top minus the top term times the derivative of the bottom over the bottom squared. So from here, if you now sub in your x value, so if we sub in the 1, we come out with a slope of 4, and now you have all the information you would need to do your point slope. So here's the point slope setup. Again, keep in mind, because of the word normal, we're not using 4, we're using negative 1 over 4. So don't forget that step. That's a really common mistake on our tests. So here we are with the point slope setup, and then clean that up as much as you can.